Alright, today we're going to discuss lesson 1.6, which is on absolute value. We're going to write and solve equations first, and the second part will be writing inequalities involving absolute value. Typically, if I ask students what they know about absolute value, is that if you absolute value a number, you just take the positive of that number. Unless it was 0, absolute value of 0 is 0, which is not positive. But absolute value, normally when I ask kids, they say, what does it mean? They say the distance a number is from 0. Like absolute value of 3 would be 3, as well as the absolute value of -3, that would also be 3. You take the positive because that's how far you are away from 0. So when you talk about distance, your answers are never negative. I wouldn't say, hey, go down to Anoka, it's -10 miles that way. You always describe distance, which is why we use absolute value, with a positive. Well, you don't always compare to 0. Sometimes you compare to another number. Anytime you have a range of values, like let's say I was doing a poll and I found that 40% of the people would vote for Joe Schmo. But at the end of that poll, I say there's a 3% error. Well, that means that I could be off by as much as 3. So it could be as high as 43 or as low as 37. Anytime you have a range of numbers compared to some, you compare a number, or compare some endpoints, I should say, to some middle number. In this case, 40 would be the middle number, and then my endpoints would be 43 and 37. Anytime you do that, you can use absolute value. So here's for your notes. Absolute value is used to describe the distance of two endpoints from their midpoint. So I'll go on and say, how do you find the distance between two numbers? -3 and 13, how far apart are they? Well, I know they're 16 apart, but can I show it mathematically? What students will do is they'll say, if I do 13 minus -3, that's 16, so you just subtract. And I say, well, how'd you know it started with 13? And they say, well, it's bigger. Well, I contend that it would be a little bit different if you didn't know what's bigger. What if I said find the distance between x and y? You can't just do x minus y. Because what if x is a smaller number? Over here, if I would have started with a smaller number, I would have ended up with -16. So what takes care of that when you're finding the distance between two numbers and you don't know the bigger is you just simply absolute value the difference that you're finding. And if you do that, you get the same answer for both. So how do you find the distance between two numbers? You subtract them and then absolute value. And if you do that, it doesn't matter which order those terms are in. So down here I've got 2 points. I got my -3, I've got my 13, and I'm going to show you how to write an absolute value function for that. Write an absolute value function for that. You will find the midpoint first. And the quickest way to find a midpoint is basically find the average. To find the average of these two numbers, you'd add them up and divide by 2. So you find the midpoint is 5. 5 is dead center. How far is the midpoint from either endpoint? Well, 5 is 8 away from 13, and 5 is also 8 away from -3. So how far? What's the distance? It's 8. This is how an absolute value function is written that describes that situation. The answers I'm looking for, the things that were graphed, were 13 and -3, but they're two different numbers. They vary. So they vary, so I'm going to say, instead of writing 13 and -3, I'm going to say x, and that stands for my endpoints, which in this case were 13 and -3. So I want to find the distance between 13 and -3, which is x, and the middle, which was 5. To find distance, I subtract those two things and take the absolute value. So this means the distance between my endpoints and my midpoint, in this case, is 8. That's what an absolute value function written in that form means. Let's take a look at another problem here on the other side and interpret what it means before I actually show you how to solve it. So here I have absolute value x minus 8 equals 6. If I were to say, hey, absolute value of what is 6? I bet you guys would say, well, it could be 6 or it could be negative 6. And keep that in mind when we turn around and solve these. But now, what does it mean in terms of a graph? Well, if I was going to graph absolute value of x minus 8 equals 6, I'd recognize that 8 is my midpoint. And the distance from 8 to my endpoints, which are x, is 6. So I would need to go 6 this way, which would put me at 14, and 6 this way, which would put me at 2. The answers to this are 2 and 14. Now, I'm not expecting you to try to come up with a graph each and every time, but I'm trying to show you what it really means. What I would want you to do is to say, okay, we're going to set up 2 equations because we're going to need to get 2 answers. Usually we get 2 answers. In this case, my 2 answers would come from the equation x minus 8 equals 6. The inside right here could be 6. So x minus 8 could be 6. But also x minus 8 could be negative 6. If I put a negative 6 in here, that certainly gives me 6. So the expression x minus 8 could also be negative 6. You solve both of these, you get 14. You get 2. You might want to check your answers, make sure they work. There are going to be some problems later on in this section where you need to check them because you'll get solutions that don't work. So here, if you plug in a 14, you get the absolute value of 6, which is 6. And then if you turn around and plug in a 2, 2 minus 8 is negative 6. So you get the absolute value of negative 6, which is 6. So this one works for both. Feel comfortable? Let's go ahead and circle those answers. This next stuff here, you can read on your own. If you want clarification, come on in. I'll be discussing it more on the inequality portion of it. But all this really is saying, I guess, is that instead of putting plus or minus 6 on the right side, you could look at the absolute value of x minus 8 equals 6 as being this right here. You could say, instead of having 6 in here, it could be negative 6. So instead of having x minus 8 in here, you could have the negative of that, which is what I have written here, negative x minus 8. Now what happens is you divide the negative over. If I have negative x minus 8 equals 6, if I divide this negative over, and it turns into that equation that I wrote up top. Okay, so how are we going to solve this? Let's solve this first, and let's go over what it means. It's 2 equations. Always the one that's staring in the face, which is x plus 3 equals 5. The inside of this could be 5. But the inside of this could also be negative 5. We do not change the x plus 3. We just say that it could be negative 5. The work for both setups should be exactly the same. You're going to subtract 3 in this case on both of them. This one you get an answer of 2. This one you get an answer of negative 8. Plug those in up top. 2 plus 3 is 5. Absolute value of 5 is 5. And then if you plug in a negative 8 plus 3 is negative 5. Absolute value of that is 5. So those answers check. What does it mean in terms of a graph? Well, some of you will be looking at this thinking, oh, the midpoint. You said the midpoint is this number to the right of the x. You might be thinking it's 3. But you'd be wrong because this doesn't represent distance because it's adding. You don't find the distance between 2 numbers by adding. So if you thought the midpoint was 3, you're wrong because you need to change this to subtracting. And adding 3 is the same as subtracting a negative 3. So really, graphically, the midpoint is negative 3. And then the distance from the midpoint to the ends is 5. Puts me at 2, puts me at negative 8. And that's how you get those answers graphically. Number 3, we could set up 2 equations, we could do some work, and then find out they don't work. Here's what I mean. X minus 9 equals negative 7. I add 9, I get x equals 2. If I plug in 2, I get the absolute value negative 7. That's not negative 7, it's 7. So 2 doesn't check. Turn around, do the same thing. Flip over the negative 7 to a 7. You get 16. If you plug in 16, you get the absolute value 7, which is also 7. That doesn't equal negative 7. So in this situation, neither of these work, and the reason is, you should be able to tell before you even do the problem, is you can't take an absolute value of something and get a negative. There's no way. Here I got negative 7. When you take the absolute value of this in here, it has to be non-negative. It could be 0, it could be positive, but it can't be negative. So I know going into this that it doesn't work. Negative 7 stands for the distance. We would never say that a distance equals negative 7. It just doesn't make sense. We don't give people a distance of negative. And that's what this number stands for. Usually that's what your distance is. Okay? Alright, now the problems get a little bit more lengthy, a few more steps. So here's what you do if you've got more terms with the absolute value. You need to isolate the absolute value. Get it alone. Isolate absolute value. And all that means is treat this whole absolute value like it's a letter. You know, what if this was 3y plus 2 equals 5? I think you all know you subtract 2, divide by 3. That's what we do here. Don't get hung up on the absolute value of x minus 9. Don't distribute to 3. It would work here, but if there was a negative in front, you'd be in trouble. So I wouldn't advise distributing to 3. I would minus the 2. Get 3 times something equals 3. And then I would divide to 3. X minus 9 equals 1. Absolute value of x minus 9 equals 1. Then I would set up 2 equations. The first one being x minus 9 equals 1. The second one being x minus 9 equals negative 1. Do not switch the signs. On the inside, don't change x minus 9 to x plus 9. Common mistake. This one, you get 10 when you add 9. This one, you get 8 when you add 9. Hopefully that makes sense. What I'm saying here is the distance between our endpoints and a midpoint of 9 is 1. Our endpoints, which are 10 and 8, and the number 9, which is our midpoint, are 1 apart. That's what it means. Last one I'll cover on this lesson, trickier one, because it's got an x over on the right. So what the absolute value is already isolated, so we're going to set up 2 equations. The first one's always staring you in the face. Don't change anything. The second one, we need to say that we could have the opposite of 2x minus 4. So instead of 10 minus x being over on the right, we could say we could also be the opposite of that. It could be negative, in parentheses, 10 minus x. This one, we have to be careful. Negative quantity 10 minus x turns into negative 10 plus x. So you end up switching both signs over there. Has to be both, otherwise you're not going to get it set up right. Now I'll just do the steps it takes to solve these. Oh, I guess I'd add an x to the left and add a 4 to the right. And it looks like I'd want to check 14/3. Over here, I'd subtract an x to the left. And then I would add a 4 to the right. You get negative 6. And then I got to check my answers. Okay. Well, negative 6 is easier to check. So let's plug in negative 6 into the beginning part here. So I would have 2, absolute value of 2 times negative 6 minus 4. I want to find that absolute value. Well, that'd be the absolute value of negative 12 minus 4, which would be the absolute value of negative 16, which is 16. Now, is that what I get on the right-hand side when I plug it in? If I plug into the initial was 10 minus x, so it'd be 10 minus negative 6, which turns into 10 plus 6, which is in fact 16. So this one checks. That one works out nicely. The other one, absolute value to plug in 14 thirds minus 4, and I want to find out if that's the same as 10 minus 14 thirds. Get a little divider for you here so I keep them separated. You can punch this in your calculator, otherwise I'll kind of go through it quickly here. This would be 28 thirds minus 4. That'd be 28 thirds minus 12 thirds. That'd be the absolute value of 16 thirds. So I need 16 thirds on the right. On the right, I would get 30 thirds. That's what 10 is, 30 thirds minus 14 thirds. And that is also 16 thirds. So that one checks as well. Okay. So we've got two answers on this one. Both of them work. We should have negative 6 and 14 thirds. Here's my two answers right here. A lot of the time, only one of them will work. And what you need to be on the lookout for, usually, what will happen when it doesn't work, is if you plug over to the right side where there's no absolute value, you get a negative. You know, like, let's say I thought x is 11. Well, then I know that it doesn't work right away because what's 10 minus 11? It's negative 1. And there's no way to take an absolute value of something and get a negative. So if you see that when you plug in a number on the right-hand side, you end up with a negative, it's not going to work if the absolute value is isolated. So this is the lesson on the first half of 1.6, which again was solving absolute value equations. Thanks for watching. Have a great day. Okay, so what does an absolute value inequality mean? We talked about equations before, and equations just give you two endpoints, two possible solutions. Anytime you have an inequality, you're going to have way more possible solutions, generally infinitely many solutions. We need to distinguish between and or problems. An and problem is one where you shade in between two endpoints right here. So you'll generally be shading in between on an and problem. And when you see and, it's because you've got less than or equal to. Is less than or is less than equal to. So for instance, if I had absolute value x is less than something, whatever it may be, some number, when you go to graph it, it's an and situation where you're going to have two points and you're going to shade in between. Now those 2 points, they could be open circles or closed circles based on whether or not your symbol has an equals under it or not, just like the other day. Okay. Or problems, on the other hand, are when you have greater than or greater than equal to. So that'd be an or problem. So you've got absolute value of something is greater than some number. You're going to have an or problem where you have two endpoints and you shade out. And you find out, remember, absolute value is distances. Distance you want are farther away from some center. They're way over to the left or way to the right. Whereas this top one, the distances are closer to your midpoint. Remember, we're always thinking about a midpoint here. So our distances on the left and right, we're in between there. So we're between the left and the right. Our answers are between the left and the right. That's the difference. So here I have the situation. A person's checking account varies between $4,000 and $10,000. Write an absolute value inequality and graph the inequality on a number line. Slide my screen over a little bit. Okay. So we're going to graph this on a number line. What I've given you is endpoints. Your endpoints are 4,000 and 10,000. I said in between, I probably should have used the word inclusive. If I use inclusive, that means it could be 4,000, it could be 10,000, and then anything in between. So a compound inequality that represents that is simply this: 4,000 less than or equal to x, less than or equal to 10,000. If I ask for a compound inequality, that would work there. Or you could say 4,000 is less than or equal to x, and x is less than or equal to 10,000. Now, absolute value, remember, we're thinking about distance from some midpoint, so we need to find the midpoint. Well, what's in between 4,000 and 10,000? 7,000. So, to write an absolute value inequality, I'm going to say the distance between my possible answers, which could be as little as 4,000 or as much as 10,000, there's a variety of answers, so that we'll let x stand for that. X stands for all our possible numbers we could have in the bank account. The distance between that and our midpoint. And how do we find distance? We subtract and take the absolute value. Well, because we're closer to the middle, that distance is less than or equal to. And then the big question is, how far is it from the middle to either end? And hopefully see that's 3,000. 10,000 minus 7,000 is 3,000, and then 7,000 minus 3,000 is 4,000. It's 3,000 both directions. There's an absolute value inequality that stands for that situation. How do we go about solving? Okay, well, just like our equations, if you've got absolute value along with some number on the same side as it or some extra terms, get rid of those extra terms. So I'm going to change this to absolute value of 3x plus 2 is greater than 17. Now, I know that this is going to be an OR problem because I've isolated the absolute value and it's got a greater than. So I know my distances are farther out. They're greater. Distances are greater. So it's going to be an OR problem. In my answer, I should have the word OR. Now I can set up two equations. I can set up, or inequalities. 3x plus 2 is greater than 17. And then the other one would be 3x plus 2. This is where it gets a little confusing. You need to change the 17 to a negative 17. When you change it to a negative, you need to switch the sign. Now here's really what went on there. Remember in equations, if I said the absolute value of x equaled some number, like say 5, then x could be 5, but x could be negative 5. So x could be 5. Or another way to look at this, you could say the absolute value of x could be 5, or the absolute value of negative x could be 5. It's kind of tricky. But if you look at it as changing what's inside, it doesn't matter if the expression inside is positive or negative, because when you absolute value it, you end up switching it over, in this case to 17. So another way to look at this is negative 3x plus 2 is greater than 17. And then how would you get rid of that negative? Well, you'd have to divide it over. And when you divide by a negative, what thing happens? We talked about that a couple days ago. The inequalities switch over. So here, greater than would have turned into less than. Okay. I've done enough of these. I just remember that if I want to make the 17 a negative 17, I got to switch it to less than. I got to switch it from greater than to less than. Solve the 2, you're going to do the same steps. Here we're going to minus 2, get 3x is greater than 15. Divide by 3, we get x is greater than 5. Or subtract 2 over here, you get 3x is less than negative 19. Divide by 3, you get x is less than negative 19/3. Very important to have the word or there, because there's a big difference between saying and or. If I said and, you'd say really there's no solution, because there are no numbers that are bigger than 5 and also less than negative 19/3. You can't do it. If I say 6 is bigger than 5, is 6 less than negative 19/3? No, it can't be and then. It has to be or. How do you graph it? Put the small number on the left, big number on the right. Decide if your circles over the tops are open or closed. Here they're open, because there's no equals. And then we want less than negative 19/3, so that's left. And we want greater than 5, that's right. just like I said way up above, if you know it's going to be an OR problem, you're going to be shading out to the left and to the right. Okay, next problem. Here I've got a 3/4 in front. Certainly don't want to distribute that. You could in this case because it is a positive 3/4, but I wouldn't recommend it. Always look to get rid of what's outside of the absolute value. Isolate the absolute value. How do we do that? Multiply by 4/3. So I get the absolute value of x plus 7 has to be less than or equal to. I don't switch the symbol for any reason now. Now here I'm going to do some math. I'm going to visualize this as 24/1. 24 divided by 3 is 8. And then 8 times 4 is 32. Once the absolute value is alone, I know what kind of problem it is. Here it's less than, so I know it's an and problem. This is going to be an and problem. I could either write the word and at the end, or I could write it as a nice, neat compound inequality. I need to set up two inequalities. X plus 7 could be less than or equal to 32. And the other one really is saying that we could take the opposite of x plus 7, and that also would have to be less than or equal to 32. Well, that ends up turning into x plus 7 is greater than or equal to negative 32. And this is where I always start. I don't write the top, the one above it. I write right here. I just know to switch the symbol, in this case from less than to greater than, and switch the sign from 32 to negative 32. Solve both inequalities. Subtract 7 to get x is less than or equal to 25. Over here, subtract 7 to get x is greater than or equal to negative 39. Here it's possible to have a number that's less than 25 and greater than negative 39. Something less than 25 would be 20. That is also greater than negative 39. So this is an and problem. You could write your answer like this with the and. Or whenever you have an and problem, you could write it as a nice, neat inequality, compound inequality, with the small number on the left, big number on the right, and the x in the middle. It's important that the arrows face the same way, and that they point at the small number. So notice here what the small number is, it's negative 39, and here we're pointing at negative 39. So I need to make sure to point at negative 39. And here, it's pointing away. See how it's pointing away from the 25, so I need to make sure it's pointing away from the 25. And this makes sense. I'm happy with this answer because it's pointing at the small number, which is negative 39. Both of them, both this and this, are pointing at the small number. And they're at the same direction. You can never write a compound inequality like this, where the arrows are pointing both towards the middle or they're pointing at the big number. That would be incorrect. Always have the inequality symbols pointing the same direction and at the small number. All right, write an absolute value inequality and a compound inequality for a length of 24 feet with a tolerance of 3 inches. Well, tolerance, all that means is you could be off by that much. Here I don't like the fact that we have different units, so I'm going to convert those. What's probably, I would guess most of you would want to change 24 feet to inches, just so we're working with the same inches. So I've got something here that I'm happy if it's 24 feet, but I'm also happy if it's as long as 24 feet 3 inches, or as short as 23 feet 9 inches, because that would be 3 inches the other way. But rather than look at it as feet and inches, let's change them to the same. So let's take 24 times 12 over here and see what we end up with. Well, we'd have 48, 24. You get 288. 24 feet is 288 inches. So I want a compound inequality and an absolute value inequality. Well, here's the situation. It's like the first one I showed you. I'm happy with 288. But it could be off by 3. So it could be as high as 291 or as low as 285. So these are the values that make me happy. Can I write an inequality for that? Sure. It's just like the first one I showed you. I'd go 285 is less than or equal to x is less than or equal to 291. Then if I want to write the absolute value, I say the values that I want, x, could be anything from 285 to 291. The distance between that and the middle, it's minus 288, that distance has to be less than or equal to, because we're closer to the middle, 3. Compound inequality on top, absolute value inequality on the bottom. Thanks for watching. Have a great day.